The man hanging outside this tower appears to be cleaning a window, but he is also maintaining the massive vertical wall that separates a perfectly climate-controlled interior from one of the harshest atmospheric environments in which a modern skyline has ever been built. Every single day, the fierce sun stretches the glass and metallic framing systems all around his suspended position. Every single night, the humid coastal air, carrying invisible airborne salt, searches endlessly for the microscopic weaknesses that the thermal movement left behind. One enemy silently opens the tiny wound. The other enemy eagerly enters it, and the taller that Dubai chooses to build, the more surface area it generously provides for these environmental forces to attack. Dubai successfully defeated the extreme downward pull of gravity long ago, but in doing so it may have created a far more expensive and demanding enemy. That enemy is the relentless forward march of time combined with severe exposure. The most dangerous wound on any towering structure is completely invisible to the tourist cameras. There is a fundamental misunderstanding about how extreme vertical architecture actually functions in a desert marine environment. When we look up at a breathtaking skyline, we instantly marvel at the sheer height and the monumental weight being supported. We inherently assume that the greatest triumph of structural engineering lives deep inside the thick concrete core and the massive steel columns. But gravity and wind loads are predictable mathematical problems that the construction industry solved many decades ago. The true daily survival of a luxury high-rise heavily depends on a much thinner and far more vulnerable boundary. That boundary is the exterior skin of the building. This complex skin consists of curtain walls and expansive glass panels, and specialized aluminum frames and carefully engineered polymer sealants. Height alone did not help Dubai escape the unforgiving nature of the desert. Building higher simply elevated the massive exposure area directly into the unobstructed path of severe solar radiation and driving coastal winds. To me, this represents the absolute most fascinating paradox of extreme modern construction. We celebrate the structural skeleton without fully appreciating the fragile nature of the protective exterior barrier. Can a soaring tower truly be called a final victory over nature if its entire outer surface must be continuously protected and repaired just to keep nature outside? The interior holds the pristine luxury and the financial value that attracts millions of international visitors. But the exterior takes the relentless daily punishment required to maintain that highly profitable illusion. Every morning, the first environmental enemy begins pulling that vital outer skin aggressively away from its structural equilibrium. To understand the hidden vulnerability of this massive real estate market, we must completely change how we think about extreme heat. The true danger is not simply that the atmospheric temperature feels uncomfortably hot to a human walking on the street. The actual threat is the immense physical movement that the intense solar radiation forces upon the building materials. The sun acts as an invisible mechanical force that engineers casually refer to as the thermal hammer. Different construction materials absolutely do not react to the intense sunlight in the exact same manner. When the morning sun strikes the eastern facade of a glass tower, the localized temperatures rise at an astonishing speed. The sophisticated aluminum framing systems heat up and physically expand at a very specific scientific rate. The massive architectural glass panels absorb the solar energy and expand at a completely different rate. The rigid structural concrete behind the facade responds much more slowly and moves at yet another independent rate. All of these vastly different materials are firmly bolted and glued together in order to form a weatherproof barrier against the sky. Because they are bonded together, their differing expansion rates create an immense amount of internal physical stress. The flexible weather joints and the structural silicone adhesives are forced to absorb this continuous mechanical tension. During the day, the materials pull aggressively against their binding constraints. As evening approaches and the ambient temperature drops, the materials suddenly contract, and the direction of the physical stress reverses entirely. This violent cycle repeats every single day, and it compounding over the long months of the extreme summer season. The thermal hammer does not need to brutally crack the primary concrete structural core of the tower in order to win. It only needs to systematically weaken one single protective polymer layer, or slowly degrade one bonded edge, or fatigue one critical moving joint. The sun relentlessly stretches the mechanical tolerances of the building a fraction of a millimeter at a time. But extreme heat is not the ultimate killer in this complex architectural tragedy. The heat is merely the burglar quietly breaking the locks on the exterior doors. The true focal point of this engineering vulnerability requires us to shrink our perspective from the grand skyline down to a gap measuring only a few millimeters wide. A modern glass facade looks like an endlessly smooth and impenetrable surface reflecting the clouds, but it is actually a highly complex mosaic composed of thousands of individual brittle panels separated by a vast network of synthetic rubber gaskets and structural silicone weather sealants. These tiny chemical joints are the absolute unsung heroes of the entire real estate empire. When these joints are freshly installed, they are incredibly elastic and perfectly watertight. But over the passing years, they are relentlessly stretched and compressed by the thermal hammer, while simultaneously being baked by intense ultraviolet radiation. Scientific research provides a sobering perspective on the lifespan of these vital chemical barriers. The National Institute of Standards and Technology has noted broad construction industry data indicating that a massive percentage of structural sealants begin to exhibit significant failure characteristics within 10 to 20 years of constant environmental exposure. While this specific data represents the general global construction industry rather than just Dubai, it highlights a universal material reality. Polymer sealants simply lose their chemical elasticity over time. The intense ultraviolet exposure actively breaks down the molecular bonds on the surface of the sealant, causing it to become brittle and chalky. Once the material loses its vital flexibility, the daily thermal expansion physically tears the sealant away from the glass or the metal frame. This localized loss of adhesion creates a microscopic pathway that is often completely invisible to the naked eye. A luxury residential tower does not need to lose an entire glass panel to experience a significant degradation event. It only needs to lose its watertight seal at one tiny isolated location that the maintenance crews fail to reach in time. The damage is often well underway, long before the building management notices any visible signs of interior water ingress. And once that tiny invisible door opens up on the exterior skin, the city meets a secondary enemy that does not originate from the dry desert sands. The prevailing marketing image of Dubai focuses heavily on the golden desert dunes and the endless sunshine, but the most destructive environmental element targeting the infrastructure is actually the sea. The marine environment does not politely stop at the edge of the beautifully manicured beaches. Dubai can boldly place a luxury hotel several kilometers inland, but it absolutely cannot stop the ocean from traveling directly through the atmosphere. The coastal air is intensely saturated with microscopic airborne moisture and aerosolized sea salt. This invisible sea constantly drifts inland and aggressively coats the soaring vertical surfaces of the entire metropolis. The ever-present desert dust creates an additional compounding problem for the architectural facades. When the fine dust naturally settles on the horizontal ledges and the exterior metal extrusions, it acts like a microscopic sponge. This dirt traps the humid coastal moisture and the airborne chloride particles directly against the building materials. As the extreme daytime heat evaporates the water, the pure salt is left behind in a highly concentrated chemical state. This localized wet and dry cycle creates incredibly corrosive microenvironments all over the exterior skin of the building. How exactly do you design a reliable defensive strategy when the enemy does not attack from one predictable direction, but rather floats through the entire atmosphere surrounding the structure? The harsh chlorides do not possess the ability to easily penetrate a perfectly intact pane of architectural glass. But the airborne salt does not need to penetrate the glass. The corrosive chlorides merely have to drift patiently until they encounter a degraded sealant, or a weathered protective coating, or a tiny settlement crack in the exposed concrete balconies. The salt aggressively exploits the exact pathways that the thermal hammer previously forced open. Chloride ions do not have to immediately destroy the massive concrete columns on the first day of contact. They only have to slowly cross through the porous outer layers of the concrete and reach the vulnerable metallic elements buried deep inside. This is precisely why these two environmental enemies become infinitely more dangerous when they operate together in the harsh Gulf climate. The thermal hammer creates the mechanical fatigue and opens the physical pathways through constant cyclical movement. The invisible sea follows those tiny pathways and delivers the chemical weapon directly to the most sensitive structural elements. When the airborne moisture and the highly concentrated chloride ions finally penetrate deep enough into the exposed exterior concrete, they encounter the crucial steel reinforcement bars. Under normal optimal conditions, the highly alkaline nature of the concrete provides a natural passive protection layer that effectively prevents the steel from rusting. But as the invading chloride ions accumulate, they eventually overwhelm and break down this critical chemical passivation layer. Once the bare steel is exposed to both oxygen and moisture, the rapid oxidation process finally begins. The steel rebars begin to slowly corrode inside their concrete tombs. As the steel heavily oxidizes and turns into rust, the new corrosion byproduct occupies a significantly larger physical volume than the original solid metal. This expansive chemical reaction generates an immense amount of outward physical pressure against the surrounding concrete material. The internal pressure slowly builds until the concrete simply cannot withstand the immense tensile force anymore. The rigid concrete begins to crack, and eventually, pieces of the exterior surface aggressively spall and break away. This destructive spalling exposes even more of the raw steel to the harsh atmosphere, which drastically accelerates the entire corrosion cycle. The structural degradation feeds upon itself in a vicious and accelerating loop of chemical decay. The thermal hammer does not need to independently destroy the structure. It only has to shorten the path for the invisible sea to do the actual corrosive work. This undeniable chemical mechanism is a known vulnerability that every single coastal engineering project in a hot climate must actively anticipate and combat. This documented process reveals the exact mechanism that the structural engineers must constantly prevent, and the severe financial consequences that emerge when the protective exterior barriers finally fail. But the ambitious city of Dubai absolutely did not enter this escalating environmental war without weapons. The modern construction industry has continuously developed an impressive arsenal of technological defenses to aggressively fight back against this aggressive atmospheric decay. The architectural engineering deployed across the skyline is undeniably world-class and highly sophisticated. Towers like the iconic Burj Khalifa utilize incredibly advanced high-performance curtain wall systems that are specifically designed to significantly reduce the brutal impact of the summer heat. Engineers mandate the use of dense, low-permeability concrete mixtures that often include specialized silica fume additives to effectively slow down the relentless chloride ingress. They specify a significantly thicker layer of protective concrete cover over the vital steel reinforcement bars. They utilize advanced corrosion-resistant metals and apply highly specialized industrial coatings to the exposed exterior surfaces. The ambitious city employs massive pressure, equalized drainage systems within the curtain walls to safely manage the inevitable moisture penetration. But the harsh reality of structural engineering is that better concrete and better synthetic seals and better defensive technologies can only delay the inevitable attack. No engineered protective layer currently exists that can permanently inspect or autonomously repair itself. The ultimate defense against material degradation is continuous human intervention and rigorous physical maintenance. On a standard two-story suburban house, this periodic maintenance is a minor chore. But when the protective exterior skin is suspended hundreds of meters above the bustling city streets, the simple act of maintenance transforms into a massive specialized industry. The very act of applying these sophisticated defenses requires a permanent architectural commitment to accessing the facade. The towering structures require massive building maintenance units cleverly hidden within their crowns. They require specialized fixed telescopic tracks and heavy mechanized cradles permanently suspended in the high-altitude winds. The defensive counterattack against nature relies entirely on an army of workers constantly descending the vertical cliffs of glass and steel. The critical question is not whether the local engineering talent can successfully defend these massive towers. The more pressing question is the sheer economic cost of how long they must keep doing it without interruption. This brings us to the profound economic paradox and the ultimate maintenance trap generated by extreme vertical expansion. Building higher into the sky does not necessarily make the raw materials degrade at a significantly faster chemical rate, but the extreme height exponentially amplifies the immense logistical difficulty and the staggering financial cost of every single necessary repair. Simply conducting a basic visual inspection becomes a slow and highly dangerous logistical operation. Replacing a deeply degraded silicone joint requires massive specialized equipment and highly trained technical personnel operating in challenging wind conditions. The weather actively restricts the available safe working windows, further extending the required timeline for critical preventative maintenance. We can look at the official maintenance logistics of the most famous tower as a fascinating case study in vertical scale. Official data confirms that the Burj Khalifa relies on 18 permanently installed building maintenance units to effectively access its massive exterior footprint. A single comprehensive cleaning cycle of the entire exterior facade takes an estimated 3 to 4 months to fully complete using these mechanized systems. While cleaning windows is completely normal for any commercial building, this specific data reveals something much deeper about the reality of vertical scale. If a single routine exterior sweep requires nearly a third of a year to execute, then the maintenance work is no longer an occasional seasonal event. At this unprecedented architectural scale, the act of physical maintenance seamlessly becomes part of the permanent daily state of the building itself. This unending cycle requires a constant and massive injection of financial capital to sustain. The taller the city decides to build, the more structural surface area it permanently accumulates. And with that vast surface area comes an inescapable financial obligation to continuously defend it from the aggressive climate. This is where the grand engineering victory begins to intersect dangerously with the fundamental principles of macroeconomics. The city did not simply construct a record-breaking collection of beautiful real estate assets. It unknowingly signed an expensive maintenance contract with the harsh environment that possesses no expiration date. The Skyline is not only a massive collection of profitable property, it is a heavy collection of permanent financial obligations. The sheer financial weight of this permanent maintenance contract brings us directly to the fragile intersection of architectural durability and the vital tourism economy. Dubai relies heavily on projecting an absolute image of pristine, futuristic perfection to the outside world. The city aggressively promotes its record-breaking landmarks and its immaculate luxury aesthetics as the core foundation of its global tourism brand. Official tourism data proudly points to the more than 17 million international visitors who arrive expecting a flawless luxury experience. Therefore, the towering glass facade does not just have the functional engineering job of stopping the heat and keeping the expensive climate-controlled air safely inside. The facade carries the immense economic burden of maintaining the flawless psychological image that keeps the international tourists spending their money. A luxury brand cannot afford to display the ugly visible symptoms of advanced chemical aging. The hotels and the vast retail sectors require incredibly high and consistent occupancy rates just to remain economically viable. This creates a highly sensitive and potentially volatile economic feedback loop. The massive fixed costs required to constantly operate the building maintenance units and replace the degrading sealants and prevent the inevitable concrete spalling must be continuously funded by strong hospitality revenues. But the global tourism market is incredibly sensitive to changing geopolitical realities and sudden regional instability. If regional tensions create unexpected aviation disruptions, or if increased competition from neighboring Gulf nations causes the crucial hotel revenue per available room to temporarily drop, the financial pressure on the property owners escalates rapidly. The daily operating revenue might fluctuate wildly due to global economic pressures, but the aggressive chemical attack from the thermal hammer and the invisible sea never stops. The salt and the sun do not grant financial pauses during a temporary tourism downturn. If the critical hospitality revenues begin to slow down, the massive property owners face immense pressure to subtly delay their highly expensive preventative maintenance cycles. But delaying the vital maintenance in this specific climate only allows the invisible microscopic failures to rapidly accelerate into highly visible and exponentially more expensive structural damage. Dubai brilliantly built its glass empire to beautifully reflect the promise of the future. But to successfully prevent that pristine reflection from being slowly covered by corrosive salt and the harsh reality of time, a heavily funded army must remain permanently suspended on the outside. Is this massive ongoing operation still a triumphant city successfully conquering nature? Or is it simply a city currently wealthy enough to keep hiding how quickly nature tries to return? The illusion of permanent architectural invincibility is becoming increasingly harder and far more expensive to continuously maintain. The soaring towers defining the modern Dubai skyline will likely stand tall for many decades, and some will undoubtedly survive far longer than that. The point of this rigorous engineering analysis is not to predict an apocalyptic collapse. Nature absolutely does not need to spectacularly knock these massive buildings down tomorrow in order to claim a quiet victory. The relentless thermal hammer only has to keep moving their rigid materials back and forth every single day. The highly corrosive invisible sea only has to keep patiently searching for the weakest, tiny opening in the degrading chemical seals. The city must proactively inspect every single mechanical joint and meticulously preserve every protective coating and physically reach every isolated section of the soaring facade, again and again. The environmental enemies only need one single neglected pathway to begin the devastating chain reaction of internal corrosion. That is the chilling asymmetry hidden deep inside the philosophy of extreme vertical expansion. The glorious act of construction only happens once. The brutal reality of environmental exposure happens every single hour of every single day. Dubai built aggressively upward in an ambitious attempt to completely escape the harsh limits of the desert landscape. But every new vertical meter added another vulnerable surface that must be fiercely defended at great financial cost. Nature may not aggressively destroy the famous skyline in one sudden catastrophic event. It can effortlessly achieve something much quieter and far more insidious. Nature can patiently force the skyline to pay a massive and endless financial tax simply to remain unchanged. Dubai spectacularly defeated the downward force of gravity once. It must successfully defeat the extreme heat and the corrosive salt and the passage of time every single day. The technical information and the economic analysis presented in this video are based on public engineering data and architectural research regarding material degradation in harsh marine environments. This documentary analyzes general systemic pressures and maintenance challenges and does not claim that any specific building in Dubai is currently failing or facing imminent structural collapse. The Burj Khalifa and other landmarks are utilized strictly as case studies to illustrate the immense logistical scale of vertical maintenance. Economic conditions and global tourism trends are naturally subject to change, and this content is not intended as financial or investment advice. If a rapidly growing city must spend forever aggressively resisting the surrounding environment just to remain unchanged, has it truly conquered nature, or has it only rented a very expensive temporary victory? Tell me exactly where you draw that complex line in the comments below. And please subscribe to the channel, because our next deep investigation goes far beneath another famous landmark to critically examine the hidden mechanisms desperately keeping it alive.